So do you see the problem? Yeah. This is a common problem. People confuse moles with molecules all the time. Moles and molecules are not the same thing. You know, a mole, it's like saying a dozen. Is a dozen a molecule? No. And so a lot of people think of this because it kind of looks like molecule, MOL, but it's not. And so 3.2 times 10 to the 24, this should be not moles, this should be molecules. And then it should be 6.02 times 10 to the 23rd molecules of SF4 per mole of SF4. Then we have the molar mass here, moles cancel, and that gives us grams. So we end up with 12.7 times 10 squared, 170 grams. This is what we left off last time? Yes. Okay. So, yeah, there's a problem with this slide. It's hard to see because of moles and molecules. All right, this is just the standard equation for percent. This is going to be percent of anything, percent A. So it can be like percent nitrogen and fertilizer. We did that. So it would just be, in this case, parts. This is percent by mass. So if it's mass, then we need to know how many grams, pounds, ounces, whatever of A we have over the total grams, pounds, ounces. Units can be anything as long as they're the same here. Times 100%. So we did that for nitrogen and fertilizer, but we could do that for anything. You know, oxygen and water, hydrogen and water, etc. Or it could be not by element. It could also be by compound. So let's say you got a mixture. This mixture is pine oil. For pine oil, we don't want to break down pine oil by element. You know, like how many grams of carbon are there in pine oil? No, we're probably more interested in how many grams of specific compounds are in pine oil. And so this could be parts of compound A or element A. And so let's look at this example. Calculate the mass percentage of fluorine and calcium fluoride. And so here we're looking at the elemental composition of this compound. But, you know, that kind of makes sense. If we have a compound, we want to know its elemental composition. But sometimes we could have a compound and we wouldn't want to know its elemental composition. We might want to know, like, what is its percent water? You know, the other day there was that one compound that we saw that weighs almost twice as much, you know, when it's hydrated than dehydrated. You know, the copper 2 pentahydrate. And there's so much water in there. And so the hydrated form weighs about twice as much. It's like 50% water, the hydrated form. And so, well, if we want to figure out how much fluorine there is in calcium fluoride, then first we got to figure out what is the composition of calcium fluoride. So what is the composition of calcium fluoride? I think we did this, did we? Ca2. Then we got to ask ourselves: are they asking for mass percentage or atom percentage? In this case, mass percentage. And so what we need to know is, you know, how much or how many grams or how much fluorine is there in the whole.
38.
Yeah. And so here we look at calcium. Calcium is, what's the mass of calcium? So we'll get that off the periodic table. Here. Yeah, 40 point. Calcium's 40.0 what? 08. Here we're going to round it. What are the units here? Okay, we have a choice, two choices. We could say 40.08 U per atom or grams per mole of atoms. So if I had 604 million trillion atoms, it would weigh 40 grams. If I just had a single atom, it would weigh 40 U. In nature, would I expect a calcium to exist that weighs 40 U? No, because of isotopes. But if I had that mixture of isotopes, and I had 602 million trillion of those, all mixed together, then it should weigh 40.08 grams. It should be accurate, no problem with that. All right, then we have two fluorines. And so this is going to be 2 times 19.00. And what we'll do is we'll probably just leave off the units here, since we can use either. So this should be 78.08. 8.08. Now, are we going to be working mainly with individual atoms, individual molecules, individual formula units, or moles of atoms, moles of molecules, and moles of formula units? Moles. And so I'm going to shift it. I'm going to bias towards grams per mole. This is more convenient to do it that way. And so, so if I want to present fluorine, I need to know how many grams of fluorine. Well, there's 38 grams, as was mentioned earlier. So 38.00 grams of fluorine. We don't need the units here as long as they cancel. If I had a mole of this, you know, if I had a mole of this, 602 million trillion, I'd have a total of 38 grams of fluorine over 78.08 grams total. Let's cancel, times 100%. So what does that give me? 38 divided by 78.08. What did you get? 48.66. Give me one more digit. 8? Is that right? Yeah, thanks. Percent fluorine by mass. And so this is going to be rounded to the correct number of sig figs. I'm allowed 4 sig figs here. It's going to be 48.67% fluorine. Calcium is in the family of the alkaline earth. Fluorine, you know what family fluorine's in? Fluorine, these we call the halogens. Fluorine, chlorine, bromine, the halogens. And so we end up with 48.67%. 48.67%. This is the grams of calcium. You know, here, well, of course the moles cancel. If I say I have 1 mole, then it's that many grams. If I have 1 mole, cancel, it's 38 grams over 38.08 grams. That's 100. The grams cancel as well, too. Calculate the percentage composition by mass of aluminum sulfate. So let's do this. Oh, shoot. I'm unplugged. All right, first thing we got to do is figure out the formula for aluminum sulfate.